Cast is now starting. All attendees are in listen-only mode.
Good evening, everyone, and welcome to this evening's webinar titled Getting the Most Out of Your Vaccination Program. My name is Jay Parsons with the University of Nebraska-Lincoln, and it's my pleasure to be your host and moderator this evening. In a moment, I'll formally introduce this evening's speaker, Dr. Brett Taylor, Director and Research Leader at the USDA ARS Sheep Unit up in Du Bois, Idaho. But first, I'd like to thank the Let's Grow Committee of the American Sheep Industry Association for providing funding for this evening's program. Without them, none of this would be possible, and I encourage all of our listeners to visit the American Sheep Industry website to learn more about the industry and to access a large volume of resources they have available there to help you be successful in the sheep business. The URL for the ASI website is www.sheepusa.org. You can access the Let's Grow program materials by clicking the link for it on the home page. I'd like to remind our listeners that this webinar is being recorded, and all webinar registrants will receive a follow-up email within the next 48 hours with a direct link to the webinar recording, as well as a link to access the webinar slides. These materials will also be posted on the Let's Grow website, along with all of our recordings from our past webinars that are up there. So feel free to access those when you have the time. We're slated for about a 45-minute presentation, followed by about 20 minutes of questions. Feel free to submit your questions at any time, including during the presentation, by typing them into the question box in the lower right-hand side of your control panel. I will be monitoring those questions throughout the presentation, and then I will moderate them to our speaker during the Q&A session after he's done with his presentation. If you have a microphone connected to your computer and you'd like to ask questions directly of Dr. Taylor, you'll also be able to do that by raising your hand using the hand icon that's in your control box. I'll go over that again before we actually start the Q&A session. So with that, it's my pleasure to introduce this evening's speaker, Dr. Brett Taylor. As I mentioned before, he's the director of the USDA ARS U.S. Sheep Experiment Station near Du Bois, Idaho. His research programs are focused on keeping profitable and responsible sheep enterprises on the range. Specifically, his research addresses the livestock production-wildlife interface, alternatives to antibiotics, selenium metabolism, improving lifetime production yield of range sheep, managing shrublands, and developing sheep breeds for range-based systems. Dr. Taylor's degrees are in biochemistry and animal science with an emphasis on toxicology, nutrition, and molecular biology. These were obtained from West Texas A&M University and New Mexico State University. He's also authored or co-authored over 90 peer-reviewed articles in numerous scientific meeting and popular press articles. So, Dr. Taylor, it's a pleasure to have you here this evening. I'll turn the floor over to you, and I'll be back to help moderate the Q&A session when you're done.
Thank you very much, Jay. I certainly appreciate it. Thank you, everybody that's out there that has logged in to this webinar. It's an honor to present this material. Getting the most out of our vaccination program. And the abstract that Jay had floated around to those that have logged in is one thing to set the foundation for this talk is that we're not going to specifically talk about the vaccines and the diseases and what vaccines may or may not be out there available for specific diseases you may encounter. That's another talk. This talk, however, is to really look at the foundation of what our vaccination programs hinge upon within the biology of that particular animal. And so for those of you that do vaccinate, and I do hope that that's the majority of you that vaccinate your flock, this really is to challenge you to take your records, look at your records, look at in the past diseases you may encounter in your region or particularly on your operation, as well as your strategies, your vaccination program, and ask yourself, am I getting the most out of this program? Because certainly in any type of production agriculture, the overall goal is to get the most output based on any level of input that we apply to the system. Now, so this at the end, I hope that I will equip you to be able to give you the tools to provide a fair evaluation of the system and determine where improvements can be made. Whereas for those of you that don't vaccinate, this is to challenge you to sit back and take the information and again, put out on a piece of paper, looking at your records and look at the issues you have, and to ask yourself, have I fully justified in not choosing to vaccinate? So in accomplishing that, I'm going to drag each one of you through my type of learning process. I'm either a slow learner or a stubborn learner. I don't know which one it is, but for me, if somebody provides me a recommendation or provides me an equipment, if I understand the fundamental basis that went by in developing that piece of equipment or machinery or developing that recommendation, it allows me to apply that knowledge more precisely by understanding what all is behind it, so that when I make a decision to provide a certain input or to use that piece of equipment, I can use it more effectively, or I can initiate that recommendation more effectively. So in doing that, we're going to go back to the classroom, do a little bit of Immune System 101, Vaccination 101, and what I call the ruminant dilemma. So a little bit about ruminant physiology related to the immune system that may be different from us. And then we're going to jump into the final part of the particular program, and we're going to focus on vaccination strategies, and in your program as an example, that will increase the health of our lambs. Because when you look at the national averages in terms of death of lambs from birth through weaning, it's a lot higher than I think that we would like to see. And although the industry is wanting to see, at least the slaughter industry is wanting to see more lamb on the rail, more lamb entering the slaughterhouses, and a lot of recommendations have been made for producers to increase or to introduce a genetics that are going to produce daughters of higher ovulation rates, we have to back off first and really look at the survivability. If we don't address the survivability issue, then what good is it to give birth to more lambs? And so that's where we'll focus there in terms of vaccine programs, or how to evaluate your program to see if you're being effective for your lamb health. And then we'll kind of conclude with a short couple of slides on production environment and vaccination schedules, and then finish up with the Q&A session. So Immune System 101. Now, I love the immune system in terms of all the things that I've studied throughout my career. This is, to me, one of the most fascinating systems that we have going on in our bodies. In fact, it just makes me proud to be a living organism on the face of this earth, to have this particular system thriving in my body. And when we look at the immune system, there are a number of different components. Innate immunity. Innate immunity is basically that barrier, that immediate barrier. Actually, your epithelial cells on your skin cells, could be considered an immediate barrier. You can throw a rock at it, you can throw a baseball at it, it'll hurt, but it's going to stop those. It's immediate, but it's not specific. Whereas the adaptive immunity, as the word implies, it has to adapt to a specific threat and then make a specific attack against that threat. In vaccination, we leverage the humoral response system for a vaccination. The humoral response consists of B cells that produce antibodies, and those antibodies are the specific target against that particular invading organism, or that invading body, or whatever it may be. So we're going to have to pause. I just had something I didn't expect to occur. I'm going to have to refire this talk. I had automatic shutdown. Give me just a minute. But anyway, as this thing's firing off again, I'll just continue. Well, no, we're about there. Give me just a second. I apologize about that. It's when you don't want these things to happen, they just seem to happen. Okay, back to the antibody, that very specific antibody. So an antibody is indeed a protein. And a lot of times when we think about proteins, we're thinking about our dietary intake. Oh, we got to consume this amount of proteins, or I make sure I have to deliver a certain amount of protein to the ewes that I'm flushing, or whatever the case may be. And so that causes us to think of proteins as this common a group of feedstuffs, like we see starch. We get starch out of corn, wheat, grain, potatoes, but starch is starch no matter where you find it. However, protein, there are tens of million different proteins, and proteins perform a very specific function. So there are tens of millions of different specific functions that an individual protein may perform, such as your muscle fibers, so you can flex. Your reproductive system functions off some protein hormones. Our immune system functions off of the antibody. One of the proteins is an antibody, and it has a very specific function. So Think of it as you're driving through an industrial park, you're driving through a business park, you're driving through a housing district. You have all of these different buildings, and let's say all of these buildings are block-based, concrete block-based buildings. Well, for an industrial park, an engineer would look at a particular building to be built and decides what's going to go on inside of that building, and it's going to construct the blocks, different densities and different sizes of blocks to accomplish what the purpose of each room in that building and the overall building is to be. An architect would step up and say, well, if it's going to be this type of building, it has to look a certain way. So they're going to have different colored blocks and different textured blocks to give the appearance. This is all put into a blueprint, much like a protein. Your DNA is the blueprint. Your DNA has genes specifically to develop to code for a specific protein that a cell is going to make. So for the B cells in the body, they have to make an antibody, and the components of an antibody are heavy chains, these inner chains, and then light chains, these outer chains. And to be an antibody, and an effective antibody, now realize an antibody's main purpose is to stick to something very specific. If the antibody doesn't stick to anything very specific, then it's of no use to the body. So we have to have an antigen binding region. Now, an antigen, that could be any component on a virus, on a bacteria, a toxin, or whatever it may be, that this antibody is going to stick to. We also have to have a cell surface binding region. Why do we have to have that? Because a lot of us, I mean, I used to think this way, that an antibody was like a bullet or a missile or something. I've got to have a bunch of antibodies to kill the flu virus that's coming around. But that's not the purpose. An antibody does not kill anything. What an antibody does is it's the flag of death. It's the mark of death. If it sticks to something, this tells the body, big cells like this, an example would be a macrophage, this tells that macrophage that that foreign body doesn't belong. And this macrophage has receptors that recognize this portion of the antibody, and then it can engulf that foreign invader. Let's say this is a virus, and then do away with the virus. So remember that your antibodies are basically the mark of death. Now, antibodies have what we call highly variable regions. Why so? Over your lifetime, you're going to be exposed to over 100 million different antigens that could be attached to a number of different foreign invaders that your body has to recognize in order to neutralize that invader. And you're like, wow, how can we have 100 million different antibodies to recognize these antigens? Well, like I said, this is the part that makes me proud to be an organism on this earth, is that on the highly variable regions on each one of these proteins, as we look across it, we have different DNA gene segments that code for the structure of that protein at this end. Now, when we're born, we've always been taught, and it's true, that we get a copy of DNA from our parents, one from our mom, one from our dad. Those are combined, and then every cell that replicates after that, from when we were an embryo to where we are even sitting in our seats right now, have the identical copy of that original DNA, and that's true. But for a B cell has a very unique ability to alter that rule just a little bit. The gene segments that code for these regions on the highly variable regions, the B cell has the ability to literally, it's almost, not exactly, but it's like scrambling the DNA to where it can make that protein just a little bit different in a whole number of different spots on that segment, and that segment. So when you multiply the overall total combinations and then occurring 4 different times over this antibody, what happens is, and this is done randomly, you have basically randomly, you can produce 100 million different antibodies to bind specifically 100 million different antigens. So it's an amazing process. And the reason we're going so basic in understanding this is when we elevate this back through the B cell and how that B cell produces this antibody, it helps us understand how the importance of our vaccination program and how to best time our vaccination program to where that we are going to maximize this process quickly and effectively for the B cell. Now, when we talk about the B cell and the humoral system and adaptive immunity, we have 3 major tissues: the bone marrow, which that's where the progenitor cells are. The progenitor cells are, I guess, what you could call infant cells, and they can be recruited to replace dead cells in a number of different tissues in the body. But the immune system is highly dependent upon the bone marrow. Without the bone marrow, you would not have an immune system. And so B cells are recruited from the infant stage to maturate into what we call a pre-B cell. And the importance, what defines a B cell to ultimately be a mature B cell is the fact that it can produce antibodies. Now, we talked about that little DNA scrambling thing going on and that's random. Well, from the process, as that B cell goes to a second important tissue of the immune system, the lymph cell or the lymph tissue, is that it's finally going to scramble randomly and make this antibody, but once it makes this antibody and expresses it on the surface, when it becomes a mature B cell, that scrambling is fixed. No longer can those gene segments be scrambled. It is fixed permanently for the remainder of that B cell's life. Not only for the remainder of that B cell's life, but when this B cell starts to divide and make daughter cells and granddaughter cells and great-granddaughter cells, they will be identical clones to that B cell, making that one very specific antibody that was randomly formed. Now, so the other tissue that's important to your immune system besides bone marrow, lymphoid tissue is the circulatory system, your blood system. This provides a rapid transport vehicle for immune cells and antibodies. It also provides a rapid transport vehicle for pathogens as well. Now, if you encounter, let's use yourself as an example, you're at work or home or wherever your environment is and you are around somebody with the flu. So if you are naive to that particular flu strain, then that flu virus is going to enter your body and it's going to enter at high loads. And this is the part where your bones ache. You're getting fatigued, you're tired, and you're like, oh no, I'm getting the flu. Well, in that process, remember, you're naive to it. But if one of those antigens on that virus happen to stick and be an exact match for that particular antibody on that B cell, that's very important, because what that does is that kicks in an activation process first to tell the body, saying, hey, this immune cell, it turns on a switch, and that switch says that that immune cell, that B cell that makes that one very individual specific antibody, is going to have to be maintained. And in that process, it communicates with other parts of adaptive immunity to alert that. Again, remember, adaptive immunity is we're getting very specific. It's a targeted effect against a targeted organism or invader. So there are some B cells that secrete some minor specific antibodies that are general clusters of antibodies that can go out and begin to tag a virus, so that big ugly blue cell in the former slide can come start recognizing them to do away with that. But remember, again, in this naive response, you're getting sick. You've had to take off work. You're at home. You're in bed. You are experiencing this flu, the full symptoms of the flu. But in the background, it's adaptive immunity. It takes time, 3, 4, 5, 6, and 7 days to really upregulate. And what we're looking for in this response, besides all these other responses, is division and proliferation of this very individual cell. Okay, and this is a primary response. Now let's look at, as we're proliferating, 1 becomes 2, 2 becomes 4, 4 becomes 8 process. Is that when we look in the primary response, what happens is that although these are identical clones to the original, these cells can differentiate into 2 types. One is a very active, aggressive type that's short-lived, and its purpose is to flood the system with these very specific antibodies to tag the antigens on this virus, if we're talking about the flu virus. So again, it can be marked, these viruses will be marked for death and destruction. But there's another very important cell that it can go into. Instead of being hyperactive, it goes into a resting state. Now I put the Z's to indicate sleeping. That was a bad example. It's really not sleeping, it's monitoring. It's at rest, but it's monitoring. It's hanging out in your lymph nodes, monitoring what's going on. Now, why is this so important? Well, this is the break between the primary response and the secondary response. So 4 weeks later, you're back at work. Everything's, well, hopefully your flu didn't last that long. But anyway, 4 weeks later at work, you bump into somebody that had the same flu. Why don't you get sick? And why did they go ahead and have the full symptoms of the disease? That's because you had banked this particular cell throughout your body, multiple copies of it in your lymphoid tissue. And as just a few particles of that virus enter your system, that cell immediately wakes up and induces a mass proliferation times thousands and thousands of cells that are also at rest and recognizing this antigen. Then you really get your hyperactive plasma cell that rests back in your bone marrow, floods the system, and there you go. You've neutralized that particular virus before you had the symptoms, before it was able to manifest itself and cause the symptoms of having the flu. So this is a secondary response. The secondary response is extremely rapid and it's extremely aggressive at a high scale. So point number 2, the secondary response. Now, before we jump out of Immunology 101, let's consider something. If that pathogen is never encountered again in humans, because we're long-lived in a long period of times, and a lot of times that will be years, then that memory B cell will ultimately die. With the death of that very specific B cell that's designed very specific antibodies against that specific pathogen, with the death of that memory B cell, the death of your rapid response dies too, meaning that later down the road, if you encounter that pathogen again, then you're going to have to go through all of the primary response, which means that you're sick again, okay? Again, to have that process to identify and find that one cell making that one very specific antigen. Now remember this, point 3. Remember this particular statement here. Now, vaccination 101. Why are we vaccinating? Well, I decided even to go to the most basic part and just pull up a definition. And of course, our wonderful internet has many different definitions. But this one I think that best, by MedNet, best fits our scenario here, and they're all about the same. So it's the injection of a killed or modified microbe, or possibly a modified toxin, in order to stimulate the immune system against that microbe, thereby preventing disease. So vaccinations, or immunizations in human medicine, what we term it as, work by stimulating the natural disease-fighting system of the body. So that's important. In short, vaccination is preventing disease by stimulating the natural disease-fighting system of our body. So it's a tool to prepare your animals for an upcoming disease, a tool to leverage the natural component of our body. Now, think about it in your sheep, is that it makes the most sense for us to leverage those natural systems before we start outsourcing other items such as antibiotics or whatever. Let's make the most of what we already have at hand that's inherent in that particular animal, and let's optimize that as best as we can in order to take care of the disease, because really the immune system accounts for neutralizing the majority of all the diseases. Our antibiotics that we may or may not use are only a small blip on that as far as neutralizing diseases. Now, what a vaccination, or the product vaccine, what it's not. A vaccination is not introducing a disease. A vaccination, the vaccine contains modified or killed components. This is Campylobacter jejuni, responsible for the old term vibriosis, the abortion that will occur near lambing. So the company will take segments of this killed organism, all of its segments, whatever it may be, and basically injecting that into the animal then will allow the animal to be exposed and begin to recruit that particular B cell without causing the disease. So it's not introducing disease. It is not passed from the mother to the young. Now we're going to talk about passive transfer in a little bit, but that's a completely different deal. What I'm saying here is although you have a B cell inside you that's selected against that pathogen and it has that genetic code, that genetic code to make that specific antibody is not in your gametes. It's not in the sperm. It's not in the egg. So therefore, it's not heritable. Genetically, you cannot pass that to your offspring. Okay? So that means the offspring has to endure the disease or be vaccinated in order to form their own response to select that very specific B cell. It's not a one-time fix-all silver bullet. This is why, especially in human medicine, every time you go to the doctor and you got one cut, you got the nurses running after you with the needle, and what it is, it's a tetanus vaccination. They're going to get you with that. And they want to make sure that basically all of those specific B cells that were targeted against that organism have not died out. So that's the importance of the booster program. It's not always 100% efficacious. One component is that you do have animals in your flock, just like we see humans, that have immunodeficiency issues, and therefore the vaccine is not as effective. And so even though you vaccinated, you still see ewes come down or lambs come down with the disease. The other part of efficacy has to do with the vaccine companies. They work as best they can to identify the concoction for that vaccine that's going to help your animals recruit the cells that they need to fight that disease. But sometimes in early development, they're not really recruiting the right cell, or the vaccine's not, and therefore you know, it only worked on half of the animals, but the other half still got sick. So in vaccine companies, the good ones are usually open about that, saying this is only a 70% efficacy or an 80% efficacy. The last thing, a vaccine is not an antibiotic. I've asked producers, do you vaccinate? And they're like, no, we're certified organic, we're natural, and therefore we don't use antibiotics. And I'm like, well, no, I didn't ask. We didn't talk about antibiotics. I'm like, do you vaccinate? Realize that vaccines are allowed for certified organic systems. In fact, they're encouraged. So some examples of vaccines that we use in sheep production, well, you know, the clostridial, especially what causes enterotoxemia is the Clostridial perfringens and the toxoid C and D. That's pretty much common across the United States, North America, and people using this particular vaccine, especially tetanus is thrown in that group. There's vaccines against the campylobacters. And regionally, some people have issues with sore mouth, other areas don't. So those other areas may not vaccinate, while those that see it quite common, especially if you're buying a lot of sheep and importing them into your herd. Remember, when you import genetics into your flock, you're also importing the disease that those sheep may carry. Caseous lymphadenitis, the one that's rising, especially for wool producers, because that can be passed in the shearing process. If you open a wound on one animal and then you open a wound on the next animal on the shearing equipment, that also can be an issue. But here, like I said, I just threw a few up that are common. Now, vaccination, the stages of vaccination. Now, think back to the immune slides. We talked about the primary response, we talked about the secondary response, and we talked about what happens if that pathogen is never encountered again regarding the death of those specific B cells. So we emulate that in our strategies. We have a primary injection. That is the initial exposure of the animal to a vaccine or an antigen. The animal is naive. It's the first exposure. It is critical, remember back to the immune system, it's critical for selection of that B cell with the randomly produced effective antibody. It's critical for selection so that B cell can divide, and we have a few of those cells scattered throughout our body and our lymph tissue. The secondary injection, the follow-up, and your manufacturers usually, most manufacturers are 4 to 8 weeks later, it's critical for initiating mass division. So you've got a few of the B cells you need scattered throughout the lymph tissue, but now we really want to readily mass populate these tissues with that B cell, that memory B cell that's going to elicit the rapid response. Then you have your booster. And for livestock animals, we look at these on an annual basis. And this is to ensure that we maintain that effective line and we don't allow that effective B cell line of memory cells to fade or die away to where our animals are going to have to go through the disease again. So remember, primary, secondary, and booster injections or vaccinations. So now let's look at ruminant physiology 101, specifically with the immune system. But I think it's best if we understand how immunity in terms of passive transfer occurs in humans. So, and when we look at most species, mammals, passive transfer is a transfer of maternal, your mom's antibodies to the offspring, to you. It's critical for survival. Maternal antibodies are targeted against diseases that are common in the environment. So think about it. Your mother, before you were born, she was exposed to everything that made her sick, and she's carrying sublevels of antibodies in her blood. So in utero, for humans, in utero, and then also dogs, pigs, and mice, in utero is in the womb. So, quote, you were in the womb. There are receptors on the placental tissue that actually would grab that antibody from her blood and put it in your blood. So when you are born, you are stocked, your body is stocked with antibodies that are going to be effective for those diseases that are most likely to occur in your environment. And you know, infancy for all species is where the risk of death is greatest. So it's a supplement, it's a boost. It's an immune boost, or it's an immune supplement that now you get to use some of your mother's antibodies. But realize antibodies are short-lived. They do their job, and probably starting 21 days to 35 days later, you see those antibodies in the blood drop off and go away. But when you're born as a human or a dog or a mouse, when these particular species, they are born with mature immune systems, meaning that the minute you're born, you have an immune system that can respond just like your mother. So you can begin that immediate process of B cell recruitment for that specific antigen. Proof of this is the fact that when allowed in humans at birth, a lot of infants receive hepatitis B vaccinations, because that's the reason is because that human immune system can respond immediately to that vaccination. Now, The ruminant dilemma is that we have to treat ruminants as ruminants. We shouldn't take what knowledge we know about our health and our immunity and our physiology and say, well, it must be the same for ruminants, because it's not. It's completely different. So for goats, for sheep, for cows, for bison, for elk, for deer, you name it. Passive transfer in ruminants does not occur in utero. That means your lamb, when it's born, the first breath it takes, and there may be a pathogen in the air, it has no antibodies whatsoever in its blood to combat that pathogen. Okay, that's important to understand. Ruminants, another wrench in the gearbox, ruminants are born with an immature immune system, specifically the humoral system, these B cell lines. That's kind of scary when you think about it, because we would immediately respond to a vaccination, but not necessarily a young ruminant animal. It takes about 3 to 4 weeks for them to have a fully matured immune system that can respond to a pathogen and recruitment of that B cell just like their mother. But ruminants do have passive transfer, but it's only acquired through consuming the colostrum. So in our mothers, we had those receptors on the placenta tissue that transferred the antibody from her blood to our blood, but she also had it on her mammary tissue, so we did get some value in the colostrum. But it's exclusive in ruminants at all those receptors in the mammary tissue. And so we'll look at a slide where you can actually see that process occurring. But the key thing is those infants, those lambs, excuse me, the lambs must consume that colostrum within the first 12 to 24 hours after birth. And people, I would bank on 12 hours. Now, here's the deal, is that, remember, an antibody is a protein. So we can consume antibodies and digest it for nutrition, but we don't want the lamb to do that. So there's a very special process that's only active, the first 12 hours after birth, and, you can stretch it to 24, that will absorb that antibody whole without digesting it and transferring it to the blood. So for the ruminant animal, the antibodies go from the blood to the mammary gland to the colostrum, from the colostrum into the mouth of that lamb, into the gut, and then from the gut to the blood. If a lamb or a calf fails to consume colostrum within that 12 to 24-hour period, passive transfer is not possible. It's absolutely impossible after that stage. Failure of passive transfer may result in mortality rates greater than 70%. It's a surefire ticket for death. When you look, there's 2 strikes right there. No passive transfer immediately or in utero, born with an immature immune system. Those 2 strikes are the fault of the ruminant animal itself. But that 3rd strike is your fault if you fail to ensure passive transfer, if you fail to ensure that that lamb is up nursing, that calf is up nursing, getting that early colostrum, okay? So that's an important part about lambing shed management to think about. But you're like, well, what does this have to do with vaccination? Well, now we get into the meat. So this has to do in terms of customizing colostrum. Now, I'm not talking about a product you'd buy from off the shelf to feed orphan lambs. What I'm talking about is you working with this animal right here. And this is Ella. She's one of our former employees. She retired and now is a sheep producer, and we do miss her greatly. But this is her vaccinating the ewes. And this part right here is literally the process of customizing that colostrum. And you can use vaccines in ewes before birth, before that lamb is born, in order to basically increase the amount of antibodies that will show up in the colostrum that are going to be specific for the diseases that you expect to occur or in the environment or in that lambing environment or that lamb's early life. So let's look at a little bit of data here. Being a scientist, I love data. I can't get through a talk without showing at least one graph, and we have several to look at. But this is antibody transfer. This is a customizing colostrum, an antibody transfer from the ewe to the lamb. Now, let's get these graphs defined before we dive into it. So on the y-axis, I have antibody magnitude of response. So it's fold. This is 1.1 times that. That's a 1.3 times response times 1. This bottom part that's in the red dotted area, this is the region of no detectable targeted antibody. So I'm looking for a very specific antibody, and I'm not finding it in this region. But these dots here indicate, indeed, I found the antibody in the blood or the serum, and this one would be 1.35 fold the non-detectable region, okay? So what we did, and this is the ewe, this is the antibodies in the ewe blood, we gave a primary injection of a foreign protein, a foreign antigen. And what I want you to notice is, go back to our other slides, this is a classical response that you should see anytime an animal encounters a pathogen, or you give a vaccination, you should see an immediate response. Okay. Now, this isn't a pregnant ewe. Real quick, I failed to describe this. This isn't a pregnant ewe, and this is the days before. So starting -56 all the way to -7 days, 7 days before birth. Birth of the lamb is here at day 0. These numbers are the days after the lamb was born, or the exact age of the lamb. Okay. So we gave this animal 40, 44, 46 days before this group of used lamb. We gave them their primary of this foreign protein. We gave a secondary about 14 days, an average of 14 to 18 days before the lamb was born. And look at this. This is a classical secondary response. So we're talking, remember back to those slides, we had that great proliferation of the secondary response, populating with all of that lymph tissue with these memory B cells that were very specific against that antigen. I give a small dose of that and boom, I get this nice, huge, rapid response. Now, in a ewe that's not pregnant, what you would see is you would see that antibody level, as my little cursor is going across the screen, extend way out here before it began dropping off. However, these ewes are about to lamb, and look at this crazy sudden drop right before they lamb. What's with that? That goes back to that physiological component I was talking about, where these receptors are expressed on the mammary gland, and the reason it's dropping in her serum or her blood is because it's being concentrated in the mammary gland to the colostrum. So what happens to the lamb? This is that same antibody here being consumed and transferred over through consumption of the colostrum to the blood of the lamb. So that's that same antibody, and we see it over here in the lamb now. And look at the magnitude of response. That transfer over there was nearly as big as her secondary response. So it's very efficient. It's an incredible mechanism. It's crazy, actually. But we see a very good response, and this would be what you would call a typical decay curve. I told you that these antibodies that are transferred, they basically are metabolized by the body, or if they tag an antigen, then they're destroyed with that antigen as well many times. And so we see that the antibodies disappear over time. Well, look at this distance that they disappear. You know, I kind of dip down in the non-detectable region there, but then I kind of pop back up, and that's more of an assay issue. But what it shows you is that your antibodies that were transferred from the ewe to that lamb are just pretty much about out of gas by 35 days of age in that lamb. But remember what I talked about, the maturity of the immune system in a lamb or a ruminant is they're born with an immature immune system, and starting about day 14 to about day 35, their immune system maturates to be fully functional to respond to the pathogens just like their mother. So anyway, in terms of getting the most out of your vaccination program and really focusing on that lamb, this one is a strategy that we look at in the ewe in terms of vaccinating the ewe at the right time to make sure that those specific antibody titers are going to be transferred to the lamb, so that lamb, while it's growing its immune system, maturing its immune system, it then is ready to respond, or it has an arsenal to tag, put the mark of death on those pathogens as they enter the system. Now let's look at vaccinating the lambs. So we talked about getting the most out of that vaccine for the ewes. Now let's focus specifically on those neonatal lambs. Now remember what I told you, that those lambs, young ruminants, are born with an immature immune system, specifically the system that is going to produce the B cells and the antibodies. Now let's talk about this. So I have one group of lambs here, and I have the second group of lambs here, the purple dots. On the green dots, this group, what we decided is well, how does an immature immune system respond to vaccination? Because a lot of producers do vaccinate at day 0, as soon as the lamb is born, because think about it, it's easy. And labor is such a huge component of sheep production systems. We always look where we can decrease labor and become more efficient, okay? So vaccinating, given a primary injection of, let's say, the CMD and the tetanus of the Clostridiums, which plagues our lambs, they're right there. They're not running away from you. You can easily pick them up and give that injection, okay? And so we looked at that strategy of an immature immune system vaccination, to where we gave the primary right after birth, and then we gave the secondary about 14 days later. Now, what I want you to look at these two dots. So I give the primary. Now remember, in the ewe, on that previous slide, when I gave her the primary, the next blood sample I took, she had elevated specific antibodies against that antigen I vaccinated with. But we do not see any elevation. We could not find detectable antibodies against that protein that we injected here, or that antigen that we injected here. Now, when we come back 14 days later, before we give our secondary injection, we actually did see an elevation. So what this demonstrates is this demonstrates that a day 1 or day 2 vaccination can still work, but I think it's based on the fact that our vaccine sticks around in the system long enough that as the immune system begins to mature, you start developing and being able to identify and recruit that specific B cell. Okay, so we do see a nice response before we give the secondary. We give the secondary and we get the proper response of what we'd expect after the secondary is given. So my deal is this immune system or this vaccination strategy worked, but is it the most optimal? Okay, did we get the most out of that vaccination strategy? Now over here, this treatment was, hey, we're going to let these lambs mature. We're going to let their immune system mature, and we will not give their primary vaccination until they're 28 days of age. Well, look at that. When I went back 7 days later, I found specific antibodies that were targeted against that antigen that I vaccinated with, and a nice little response. And it really popped up 14 days later, and then when I gave the secondary vaccination, then I got even a higher response. So you can see overall that I got the most out of that vaccination strategy by waiting and allowing the immune system to mature in those particular lambs. Now, let me back up. So let's say that we are going to grow these lambs out, and we're going to select our ewes and our young rams to retain in our flock, and then the ones that we don't select are going to be finished. Okay, say we're going to finish them for slaughter, or we're going to send them down the road for somebody else to finish for slaughter. And so what we looked at here is that, well, let's look at the effect of giving a booster, okay, because the enterotoxemia, the overeating disease, are going to be exposed to grains, which could be a recipe for that particular organism to go nuts, the Clostridium perfringens. But what I want you to notice, before I gave that booster at about 150 days of age on these same lambs, again, these same lambs, this group had the day 0 and day 15 primary and secondary injection. This group had the day 28 and 14 days later the secondary injection as lambs. But out here at 150 days of age, I just barely was able to detect of any remaining antibodies specific back to that original vaccination that I provided when they were young lambs. Now this is a concern. What it tells you is that, again, not only was that vaccination strategy of 0 and 15, not only was it not the best, it worked, but not only is it not the best at that time, it also has downstream effects and downstream consequences. And so, but as the immune system, there were a few of those memory cells still hanging around, or we was able to recruit a few, because after I gave the booster, then I got a nice response, and that response went on out there and began to taper off. Now for the group that I delayed the lamb vaccination to 28 and 14 days later, they had circulating antibodies. They responded very well and very high, and they maintained that high level of antibody production over the course of that period. One thing to think about is that if I had this group here and I did that strategy, you can bet that I'm going to make sure I give that booster. But this group actually had sufficient antibodies that most likely you wouldn't have happened to have given that third booster to make sure you had the right cells hanging around. So think about that. But a lot of people come back to me, and I totally am with them. I mean, I understand. I totally understand what they're saying. They're saying, yeah, but Brett, I mean, again, it's labor. I mean, I can grab that young newborn lamb up, I can give it its vaccination, and then I don't have to wait 28 days and then try to chase around and corral up a bunch of lambs that are jumping fences, running between my legs and going all over the place, kicking me when I'm trying to give them the vaccination. And I understand that. And that's the part of challenging you in your vaccination program to consider, are my labor inputs worth this shift in strategy? Because that person may say, hey, I am fine with giving that third booster vaccination because I'm going to be sorting these lambs off anyway for retention or to sell off or to go into slaughter or whatever. So they're going to be right there, and it's easy for me at that point to vaccinate. Okay, so that's really what the challenge is. I'm not saying that there's a right or a wrong way. I'm just saying that there are a lot of number of factors. There's many factors that go in determining what indeed is the best strategy or not. So let's look in the concluding remarks as we're going to wrap this thing up. Let's look at environment and schedules. Because when we look at our vaccination, I'm out in the dry desert west, and I mean it's dry. What doesn't have a little bit of water on it is turning black from burning up right now. But you look at my environment. My environment, such as on the right side of your screen there, is going to look about like this. Look at the distribution of these sheep in that environment. And basically these sheep graze from here all the way to about 35 miles away over to there throughout the course of the summer. So a dry system, very open. The density of sheep, even though there's a lot of sheep out there, they're not clustered together like this group up here in the feedlot. And therefore the chance of a disease outbreak would be a lot less. Plus that dry environment is not very suitable for certain pathogens to hang around. Whereas if I look in a climate factor, when I look at a very wet environment to where you're on pasture, so you have many, this same number of sheep, instead of on a 6,000 acre pasture, they're on a 100 acre pasture. And so the environment, again, it's wet, it's conducive for some pathogens to stick around a lot longer. The sheep are a lot closer, a lot more contact, a lot more opportunity for that disease to rear up multiple times throughout the year. Whereas this system, that disease may only occur once a year, or the probability of the disease may only occur once a year. Vectors, other animals, open flock. Do you import genetics into your flock? Remember what I said a while ago. Whatever sheep you buy to put in your flock, you bought those diseases too. Okay? Your neighbors. I mean, what's going on with your neighbors? Fence line contrast or whatever it may be. Even though you're in the same region and therefore the same probability of this to harbor specific pathogens that stick around, your neighbor's management strategy may be completely different, to where their flock could be more persistent in certain types of diseases, although your management style really minimizes the persistence of certain diseases, but they can still get it in a fence line contact environment. Facility hygiene. And this is a big one. This is a big one. And, I've seen everything from spot clean facilities with steam washers and antiseptic sprayed to facilities to where the bedding pens, you almost bump your head on the roof when you walk in because the bedding has not been changed. This is a big factor. And again, depending on what type of system you're working in or whatever you may have, is going to depend on your vaccination strategy. Are you applying that strategy to account for all of these factors, which some of these factors may or may not increase the likelihood of a disease or a pathogen sticking around and occurring and cycling through your flock over and over again? So really realize that and think about your production environment. And also you can get recommendations from people across the country or neighbors, but just make sure that, like I said, I used sore mouth as an earlier example. We do not vaccinate for sore mouth here because basically it's not an issue. And when we purchase outside genetics, we have a very long quarantine period that we monitor that. But there are certain areas that, man, they will not go by 1 year without giving their annual booster. Schedules. Timing for optimal preparedness. Remember what we talked about, the age of the lamb. Does your vaccination strategy or program allow you to let that lamb mature a little bit before you start the vaccinations? I realize here in the West that a lot of those lambs on the clostridials, they don't receive their primary vaccination until those lambs are anywhere from 90 to 120 days old. But again, go back to that dry, open environment of low density animals to where they can actually get away with that. Timing of booster and secondary vaccination and expected pathogen exposure. I've been going over and over and mentioning this probably too many times to almost bore you. But the deal is, let's use 3 common ones or 2 common ones and 1 less common one, but Campylobacter, the aborted death for the lambs that occur near lambing. The booster or the secondary being given pre-breeding to start elevating those antibodies as the breeding occurs and as they go through pregnancy. The Clostridium species, pre-lambing, we talked about hitting that U before lambing at the annual booster to increase those antibodies in the colostrum to give that short period advantage to the lamb. Also pre-growing and finishing. Is they're going on to energy diets to where the enterotoxemia, the overeating disease, could rear its ugly head. Do we have those antibody titers elevated in those lambs to deal with that and neutralize it so they don't have to endure the sickness themselves? The Corynebacterium with the caseous lymphadenitis, pre-shearing or near shearing, as far as getting, because as those organisms are transferred from one animal that's nicked to the next animal that's nicked by the shearing clippers, and that bacteria is transferred over, or antibodies already circulating to tag or put the mark of death on that bacteria rapidly. So these are some things in looking at your schedules you need to think about. Food for thought. And this goes back to the example I was given about vaccinating at day 1 or 2. There is a balance between labor inputs and maximal vaccination efficacy. Sometimes labor costs may be greater than a few losses due to disease. Okay, that's a hard thing to swallow, but really when you think about it, sometimes we're not going for maximal, we're going for optimal. Optimal considers a balance of our program, where maximal is almost like single trait selection. We're only going to do what it's going to make to get, we're going to put whatever dollars we have to get the maximal vaccination response. Well, that can kind of get you in trouble, just like single trait selection can. Optimizing means that we're going to take in all the factors, which include our labor, the number of sheep, or whatever it may be, in order to optimize and get the most out of our vaccination program. So, in conclusion, know the diseases relevant to your flock, neighborhood, and region. Consult with your neighbors, experienced producers, associations such as ASI. They have a lot of great materials, University Extension, and your veterinarian. And don't forget about your University Extension. This is the one that has the long-term institutional knowledge. This is the system that's free. I'm not putting down veterinarians. This one's not free. This one is free. So utilize your land-grant university system. It's an awesome system. Consider timing when optimizing the vaccination strategy. Remember, a proper vaccination schedule will include a primary, a secondary for naive sheep, and an annual booster for the vaccinated sheep. People, I can't emphasize this enough. I don't know how many times that I hear a producer say, yeah, I vaccinated about 4 days ago, but look, I got the problem this year. 4 years ago. I got the problem this year, so the vaccine didn't work. Remember back to the Immune System 101 I gave you. If they don't see the vaccine again over a long period of time, they'll lose those memory B cells that would allow that producer to not see that disease pop up again in this flock. Vaccination, labor, sheep sickness, and death all cost money. So therefore, again, I'm saying it again, evaluate the cost and risk to determine when and how vaccination is to be applied in your system. Please note I said when and how. I did not say if you should or shouldn't. I just said when and how. Producers should take advantage of the primary, natural, and most effective and cost-efficient method to improve flock health. It is vaccination. This is your tool to stay within that animal and to leverage the potential out of that particular animal. You are simply helping that animal select the right B cell before that pathogen comes along. So I did mention in the abstract that was sent out for the talk that I would talk about tools, and that was mainly going to be the pneumatic, the air injection that we use for vaccinating here at the sheep station. I'm going to throw that ball back into Jay's court because I don't really know what time constraints we have, but I can immediately, if Jay allows, pull a video up, take about 5 minutes explaining that. But I do want to get to the question and answers. So Jay, I'll turn it back over to you.
Yeah, we've actually had quite a few questions come in while you were talking, really good practical questions. So if you wouldn't mind, let's go ahead and tackle some of those and see where we're at on time as far as showing the tool. If that's okay?
Yes, sir.
Okay.
Yes, sir.
All right. So you mentioned Campylobacter in one of your concluding slides there on the schedules, pre-breeding. But we had a question come in where a person has purchased ewe lambs and turned them in with a ram right away. And they're wondering, can they still vaccinate them for Campylobacter? When would be the best time? And what about the follow-up for the second booster?
Yeah, the very, very, very good question. In fact, this is a common question that has come back to me over the years. And when you read the instructions I think do say a pre-breeding type scenario for the primary and secondary. But many producers are in the same situation that you are, And so I'm going to tell you what they delivered back to me. They have gone ahead during the breeding component or post-breeding component and went ahead and did their primary and followed the instructions, which I think is 4 to 8 weeks later for their secondary. Some of them, like I said, waited to breeding. I have not had any calls returned back to me saying, hey, that didn't work, or hey, that interfered with my reproduction rate. So that's kind of what I've seen applied in the industry. Here at the sheep station, we've never really tested to see if there are consequences of vaccinating during breeding or after breeding. But like I said, we've never had any negative feedback for those producers that went ahead and moved forward with vaccinating during breeding and then following up with the secondary after.
Okay. And I know you mentioned sore mouth vaccination. Somebody asked a question on the optimal timing of sore mouth vaccination for prevention of ORF in young lambs under 1 month of age.
Good question. So in this one, I'll have to admit that sore mouth, in terms of the efficacy to bring about that desired effect on the sore mouth, is something we're not too totally readily familiar with, because we don't have the issue. It's rare. And usually when we've seen it pop up, it's been more in our mature flock, and it usually was because one slipped through quarantine. And so we implemented the vaccination immediately on the whole flock to serve several years. But then again, and this is something that we need to investigate, and Jay's marking these questions down for me that I can dig a little bit and get back to the group, if there's a mass email list that Jay could leverage. But again, that vaccination of building those particular titers, so that's the level of antibodies in the blood pre-birth, as long as there is not a restriction on that particular vaccine. So everybody realize that vaccinating late pregnant ewes, you need to make sure that there's no restrictions on that. Of either building the titers in that particular ewe to concentrate in the colostrum, or, like I said, lagging a little bit on those lambs, lagging a little bit and getting that vaccine in of that young lamb. You saw the example of the issue with the day zero vaccination, but realized that it did work, and realized that there had to be a secondary, and it certainly doesn't hurt to follow that with the booster, a short run booster on that, because lambs are difficult to target, and that's because of that immature immune system. So I know I rambled a little bit. I apologize whoever asked that question, but I can look into that as well.
Okay, and I did mark it down, and I'll send that to you. So question on how long immunity lasts for CDT vaccine. I know you talked a little bit about, the need for keep boosting things, but in humans, tetanus boosters are given every 10 years. So
yeah,
sheep,
that's right.
Yeah, and sheep,
Actually,
is this an annual thing? And then specifically in terms of maximizing colostral transfer of CDT antibody?
Yep. That is an outstanding question, one that I've had to scratch my head about a lot of times. I kind of have a funny story with that. My wife will totally admit that I'm extremely accident prone, and I remember getting a cut one time, and I went to the doctor, and the nurse come running out. When's the last time you tetanus? And I said, I don't know. And she goes, well, here, I'm giving you an 18-year booster. This was about 6 or 7 years ago, so they had this 18-year booster. And I was like, well, great, man. I'm good for a long time. Well, again, accident prone. 2 months later, I'm back into an office with a cut that I was, I had it cleaned out. It was on. I was good. I was just seeing we needed to put some stitches in it. And here come another nurse, running with that syringe. And I was like, wait, I got the 18-month. And she goes, I don't care. And she hits me again. And I think that, that's erring on the cautionary side of things, in which there was no harm. But when we look at ruminant animals, they are short-lived. Okay, and I think that there's something that has to do with that in terms of metabolism of cell types in different species, that maybe our cells have the ability to live longer maybe than other animals. But the key thing about CDNT is really that focus is on the lambs. And so although there may be persistent memory cells still sticking around in that old ewe that you boosted 1 year ago, the key thing is optimization of that particular B cell and the antibody production is best focused on improving that colostrum. Because really, when you look at CD&T, the most of those deaths of the effect of that particular organism are going to occur between birth and some finishing time in that young lamb's life, you know, when it's finished off for slaughter or when you're developing that ewe lamb. So really, the annual booster focus, in my opinion, is best suited for the benefit of the lamb. However, we do need to realize that we do know, and species other than us, their memory cells are a little bit shorter lived, but they do stick around.
Okay, good. And I'm going to group these next two questions together. They came in from different people, but you'll see why here in a second. First person says, can you talk a little bit about customizing colostrum for accelerated flocks? Specifically, should we be concerned with exceeding annual booster dosages? And then another person asked a similar question, totally different, but it had to do with, let's see if I find it here, any suggestions on minimizing vaccine site reactions, knots, and why does this happen? So basically, one of these frequency questions, especially with accelerated flocks.
Yeah, no, that's a good question. I'm probably going to fall short on the accelerated lambing because my assumption here is we're probably looking at that booster hike occurring every 8 months instead of every year or something of the matter. I think that it's especially when you're going into the injection site, that is a concern. And remember, your injection site should not be in the rear of the animal moving towards the front. Remember, you're looking at the quality of that animal as they go into slaughter, even as a mature ewe or a coal ewe, and those lesions that we know and we do see in the slaughter plants develop. Boy, I'm going to have to think about the accelerated. If, you know, on 8th month basis, if that, you know, of course, you may be sooner. I don't really see an issue in using that. Now, I think going ahead and customizing colostrum or boosting those titers of antibodies, and that's going to show up in the colostrum. I think that I would be prone more to go that direction if I see and if the clostridial diseases are very prevalent in your flock year after year. Okay, a lot of systems maybe not so. Remember, going back to that one slide to where I showed the lamb, especially in those later vaccinations, that they still had, even though that was only 160 days later, but they still had measurable titers. So that may be indeed the case that if a ewe gets a vaccination, then 8 months later you're looking at a booster again to customize that colostrum, is there will be circulating antibodies. It's just that the max, if you want to, you know, really max out the level of those circulating antibodies, that's where that booster would come into effect. On the lesions, well, I'll put it this way. Our flock probably gets, our ewes probably get, let's see, 4 boosters a year for different types of organisms. So our ewe, any one ewe within a year is getting 4, and so 4 times, you know, let's say an old ewe, 7 years, she's going to get 28 hits plus the 2 for the primary and secondary as a lamb. So you're up to 28 or 30 different injections. What we've seen and the feedback that we've got back from those animals that have ultimately gone to slaughter is not seeing lesions on those particular animals. So I think that of course, we use pneumatic injection and not needle injection, but that was even so in the needle injection. But we're using, you know, when we had needle, we used to change out needles in between. So good, sharp needles. The ewe is properly restrained where we don't get any tearing or ripping, and the injection site is given precisely. We haven't seen an issue with those lesions occurring.
Okay, we had several questions come in when you had the charts up on the vaccination efficacy. You know, the green and purple dots.
yeah, that one may be a little bit tricky.
A lot of questions around the vaccination. How much variation is there in the vaccination response between what you're vaccinating for and the type of vaccine that you're actually using? Is this interpreted generically here for anything? Anyway, I guess you can just address that.
Yeah, so basically we were using a foreign protein in this particular study, and that foreign protein was chicken egg whites. So the old albumin And egg whites. And everybody's like, why in the heck were you doing that? Well, the deal is if we'd have used a Clostridium vaccine, or if we'd have used a Camp or whatever vaccine we were using, the animal, a ewe, is already going to have those level of antibodies or been exposed to that pathogen. So it's hard for me to separate out my response compared to their response. But this data does lay on top of data out of Cornell, where they actually were looking at the Clostridium response, and it does follow, let me turn my little laser deal on here. It does follow this general pattern. This is very textbook pattern with specific antibodies against pathogenic antigens, okay? This variation, it's pretty tight. So statistically, what we were seeing is the distance between these two was the distance between these two was statistically significant, meaning that the variation was very tight in all those groups of lambs that we had around this. The same thing for this next treatment group here. So we move forward with relative confidence that this is going to be relatively representative of actual vaccines that are targeted against actual pathogens, assuming that the vaccine you buy is as efficacious, has an efficacy of selecting for that specific antibody that's efficacy above 90 or 95%, meaning that the vaccine is a top and prime vaccine.
Okay. So while you have this up here, that there was a question on the later vaccination, the 28-day coming in, and about the gap. Is there a gap in antibody coverage between the colostrum supplied antibodies and in their disappearance, I guess, and then the initial ones that are generated at 28 days, and what are the concerns?
Yeah, okay, so a great question, and this is why we're looking. So I'm gonna go back a slide, but first, mark this second purple dot right here at about 1.2 fold, okay? And it's at about 35 days. So let's go back a slide, 2 slides. And remember, this was the passive transfer of that exact same antibody that was developed in the ewe, passed to the colostrum to the lamb. And then if you look out, if you actually do what we call do a decay curve, although we did kind of slip down here in the non-detectable regions, but I think that was just more of an assay issue. But if you actually plotted that curve out, what you would see is that curve is coming down and disappearing out here about the time that we decided to go in and get our primary response, which jumps right up in here. Remember, that primary response was about 1.2 fold, so it really gets up there pretty good. So my point is that, and realize, please keep this talk into context of where I'm speaking from. So again, I'm out in this very arid, dry region, to where we, as well as the 80,000 ewes that are around us from other producers, if we're looking at clostridial organisms, we really don't give our primary until these animals are 90 days of age. So that's our environment to where clostridial issues are really not a concern until we get into where we're giving energy feeds, when these lambs are 120 days old and they're going on to finishing rations, ewe development diets. But no, this right here does show a clear overlap with the delay of the injection.
Okay. And we have several questions coming in terms of access to vaccines. I don't know if how much you want to get into that, but question on, can we talk about the issue of good vaccines available in the UK and Australia that we cannot get here, even though we have a diagnosed disease they can fix? I don't know if you have any insight on that or not. If you don't, that's fine.
No, really, we live in the United States and in the Western world, and the Western world does drive off supply and demand. And we have seen this maybe in some things that we wanted, and we have developed autogenous vaccines, had it contracted a company, and that's basically a vaccine specifically against an organism that we have here, and it's pricey, it's costly. Really, other than the marketing component, I do not speak ill of our vaccine companies. I am grateful that our vaccine companies are out there, and I'm grateful that they're still choosing to invest in sheep. That is so important. And they're doing, and sometimes vaccine production, they do it as fast as they can for that given species. But a lot of it comes down to availability, especially if it may be a pathogen that we're not necessarily experiencing, but it's been imported recently from another country. Vaccine development takes time. It does take time.
Okay. Thanks. And somebody asked, some producers bunch up vaccinations like CDT and Cacius and something else and do a bunch of them in one pass. What is the effectiveness of this versus leaving time between vaccinations? Do you have any recommendations there?
Well, I'm just going to give you an answer purely from the textbook physiology response. And we know that sometimes our animals don't like following. They seem to can't read the textbook like we can. But I think this is a solid answer. That remember how I described the immune system, and remember that your immune system is developing and maturing these B cells one right after another, and each B cell has a unique, randomly produced antibody to see if it's going to be effective or not. And so the deal is even if we flood the system with all these vaccines all at once, remember one vaccine is not competing against the other vaccine. Each vaccine is going to be specific for what our body is randomly going to generate a very specific antibody. So it's not like, it's not a competition deal. You're not competing for one B cell. What you're doing is just multiply at the same time, recruiting a number of different B cells that are going to be specific for all those different antigens. That question does come up, and there's a debate. But again, I don't see an issue with it. Again, when it's balanced at optimizing their vaccination program, and that's when their labor force is most effective. Now, let's say that process may have a negative effect. I'm not saying it does. Let's assume that it did. Well, the thing is the animals are vaccinated, so the negative effect most likely is going to be small if we didn't get the level of efficacy that we were hoping for in that vaccine. And that if it is a negative effect, that negative effect is probably smaller than the whole cost of the vaccination component, of the labor component of bringing those animals in and waiting the several days. But going back to the physiology of the immune process, it's not a competition deal. Each one of those vaccines will independently work to identify the recruitment of that B cell that's specific for that particular vaccine.
Okay, and along those same lines in terms of efficiency, somebody asked if you vaccinate once, the lambs, if you vaccinate them once at 30 days old and then boost at weaning, is that going to be effective? Are the lambs protected?
No, and so really, if you vaccinate at 30 days, and remember that the weaning, it won't be a boost; it's your secondary. So you always keep those in orders. No, there are some producers that do that because that's all their system in terms of labor. It's not the most recommended, and the vaccine label will tell you that. But some people will delay out there at 10, 16 weeks. And I have seen in studies, that indeed you do get that secondary response. Now, it's just like, but realize that it's not the most optimal action, because some of those, you did recruit a few B cells in that primary response, and they're waiting to be triggered to go into a greater population or mass division. And so you lose some of those. So your secondary response may not be as great, but you will get a response.
Okay. And two more quick questions. One of them is freezing colostrum. Does it harm the effectiveness of the benefits?
No. You can freezing colostrum is an outstanding method to preserve for a day when you're managing too many orphan lambs. I've been there, and it's nice to have that stuff on hand. And so it may look glumpy and clumpy when you thaw it out, but it works, and that's effective method.
Okay. And if you have CL in your flock, would it work to give the vaccination prior to lambing to prevent this in your replacements?
CL, are we talking about?
I think Cacius lymph. Yeah.
Could you read the question again then?
It says if you have CL in your flock, so I think it'd be Cacius lymphadenitis.
Yeah.
Yeah. Would it work to give the vaccination prior to lambing to prevent this in your replacements?
Well, when you look at the spread of that particular organism, Yeah, I mean, I think you're fine, but I think you may be better off in terms of really starting to prime that. Of course, I don't know what type of environment you're in. You may be an environment where open lesions may be possibly common, but I mean, I think that would work. But also, I don't think it's a harm to wait that out as the lamb gets a little bit older, where it's handier to vaccinate the flock. But I think you could choose. The deal is if you really think about it, if you are, and I may totally misunderstood the question, and I apologize if I did. But if you're looking at vaccinating the ewe and that colostrum component, that's only going to be, like I said, those antibodies are short-lived. They're only going to stick around for 21 to 35 days. So if you see an issue in your very young lambs to where they could actually get exposure to that particular bacteria, then yeah, I guess, but really evaluate what degree of exposure would you expect in the first 21 to 35 days, when they could respond to the vaccine themselves. Now, commonly, in a lot of the CL part is for people that a lot of people shear before lambing, and that booster then, there's some of them are shearing, like we shear 8 to 10 weeks before lambing. So a lot of the Western range enterprises to get that clean clip. That booster there that they're giving around shearing or right before shearing, that antibody titer is going to last to be somewhat concentrated in the colostrum for their lamb.
Okay. I lied. We had one other quick colostrum question came in, and that's how much is needed to be effective for an orphaned lamb?
That is a great question, and especially it's that question that occurs to where somebody yells, "Anybody got any more colostrum left?"
Right.
Because I was like, "No, I used it on that last lamb, but here's a drop in the bag." Any level is effective, but I think that intake to where that initial intake to where those lambs are probably only consuming maybe 100 mils of milk in that first period, or that colostrum, you're looking at 50. Hey, I'm just shooting this right off the cuff of what I see out there. So I haven't studied this, and I haven't read it in a book or anything. But I see a good colostrum sometimes only being able to even tube some of those weak lambs. We're only 25 to 50 mils, okay, have been able to make it, and that seems to have in our system have been relatively effective. But that's just an opinion, an anecdotal observation answer. So please keep that in mind, and probably you want to seek other professionals on that.
Okay, Brett. Well, thanks. Great job with the questions and great job with the presentation. We've used up our time, but if you do want to show that video, we can go ahead and show it if you'd like. If people want to stick around,
yeah,
we're done with our
okay.
Q&A, and I'll let Brett show his little video, and then we'll sign off on things. So
yeah. So yeah, those that want to stick around. So what we're really looking at is the pneumatic injection. Now, I'll tell you right up front, $3,000 upfront cost right there. So for smaller systems, they're like, no way. This is something that I can't afford, and that's fine. I mean, that's great. I mean, whatever system you're using, just be sure if you can change your needles in between. We just use what we have available to us, and that's important. That's what makes us efficient producers. But for the larger flocks or cooperatives, so a group of producers that get together can justify this, because like I said, we're given, let's see, 2,500 times 4 is 10,000 times the primaries gets us up to, in secondaries, 15,000. We're doing 15,000 injections a year. So what it is I'm going to pause this real. Oops, it cheated on me. I'm going to show this video again. What this is in the pause slide. It's like a nail gun. This has to be pushed in at the same time you pull the trigger, which is under Ella's finger right here. And then at high pressure, and then you set the rate of the vaccine that you want to go in. So let's play it again. So watch that stream come out. You see that micro stream, and we have a publication of that out there. And what the deal is, we get a lot of people saying, "Hey, does it shoot down through wool?" Absolutely, it does. You press it up against the skin, you inject, the wool doesn't interfere it. You get the same antibody response you do with injections. In fact, you sometimes get a heightened response because it distributes the vaccine throughout multiple layers of the tissue, instead of a needle will actually just form a bubble there. and you sometimes get some leakage. Now let's go back to how fast it is. So usually vaccinating requires somebody with strength and stamina. Well, Ella has tremendous strength and stamina, but as you can see, and Ella would admit to it. I mean, she was in her later, in her 60s when she retired, and so she's kind of running out of gas. She'll admit it. But the thing is we were able to give the vaccination of even our rams and everything to her because I want you to watch. We'll play it over twice. I'm going to watch how fast that is. Bink. It's kind of jittery for you, but she just reaches over and it's that quick. I mean, it's not flowing, the video is not flowing smooth in your view screen. But look how fast that is. She doesn't have to restrain. She doesn't have to do anything, and I'll play it again. She just leans over, and just like a nail gun, like a carpenter that's shooting nails into wood, that's how that thing works. And man, it's fast. Really no physical exertion there every once in a while, except for those stubborn ones that she has to lean over and make sure they stay still. But it's a very effective process. But it does cost money. But a lot of people have gone into it, and a cooperative, and we have 2 units here. One of them is 15 years old, and it has as long as you replace the O-rings, and you have to do that into your injection syringes as well. But we're still using, take 15,000 times 15, and that's how many injections that unit has given us, and it's still cranking away.
Yeah, that's great. And like you said, if people join together in a cooperative setting, maybe they can make that work. So, all right. Well, thanks, Brett. That was really good information. A lot of good comments already came through in the question and answer box, and I appreciate everybody's questions that they sent in. We had really good questions tonight, and appreciate everybody getting on. Once again, I just want to thank the Let's Grow Committee of the American Sheep Industry Association for providing the funding for this program, and thanks for everybody for joining us, and thank you, Brett, for doing such a great job. We really appreciate the work you do up there.
Thank you.
All right, I'll go ahead and sign off and wish everybody a great evening then.
Good evening, everybody.